Dear students, I am Mahesh Javalkar from Marathamandal Polytechnic, and now I am posting my fourth video on Dcet questions for the subject Digital Communication. Now, earlier to this, I had posted three videos in which I had covered 60 questions, and now I will start from question number 61. So let's go with the question. So the first question, question number 61, says that converting analog signal to digital is done by sampling and which method? Options are quantizing, pre-emphasis, companding and mixing. So we always know that whenever we use a PCM system and whenever we convert analog signal to digital, first we make samples of that analog signal and then every sample is superimposed on a quantizing level. Quantizing levels are taken, and based on that quantization levels, a standard value is given to that amplitude of the sample, and then that value is converted into a binary data. Okay, that is quantization process. So converting analog signal to digital is done by sampling and quantizing. So here the option will be option A, quantizing. Okay, then we'll go to the next question, question number 62. A coherent ASK receiver uses. Okay, now we know that in ASK receiver we have coherent and non-coherent. So whenever it is coherent, a local oscillator frequency synchronized with the transmitter is used, and whenever it is non-coherent, that frequency is not used. But in non-coherent we use filter, whereas in coherent we use integrator method, because we have to integrate the input value with the signal which is produced, with the frequency which is produced at the local receiver, so that the synchronization between transmitter and receiver takes place. The transmitter and receiver timings are synchronized. So here the answer should be a coherent ASK receiver uses integrator method demodulation. Integrator method demodulation. So answer will be answer A, integrator method demodulation. Okay. Then we'll go to question number 63. Frequency shift keying is basically a method involving. So he has given options as amplitude modulation, frequency modulation, phase modulation, and all of the above. Frequency shift keying is a method where frequency of the carrier is varied according to the input binary data. Okay, and it resembles frequency modulation. So option B will be correct. So here option B, FM, will be the right answer. Then we'll go to the next question, question number 64. In dash, the amplitude of the carrier is varied to create signal elements, and both frequency and phase remain constant. Now, if amplitude of the carrier is varied according to the information data, okay, 1 and 0, according to that information data, if you're varying the amplitude of the carrier, then that process is called as amplitude shift keying, ASK. So here the answer will be answer B, ASK, in which the amplitude of the carrier is varied according to the information signal. Okay. Then we'll go to the next question, question number 65. In dash, the phase of the carrier is varied to represent two or more different signal elements. Both amplitude and frequency remain constant. So if you are varying the phase of the carrier and keeping the frequency and amplitude constant, then it is phase shift keying, PSK. So here the answer will be APSK. Then we'll go to the next question, question number 66. How many carrier frequencies are used in BASK? Okay, now BASK is a method in which amplitude of the carrier is varied according to the input data, according to the information data. So if the information data is 1, the carrier is passed. If the information data is 0, there is no carrier. Carrier is absent. So it requires only one carrier. One carrier is used in binary amplitude shift keying, BASK. So here the answer will be B1. Okay. Then we'll go to the next question, question number 67. Quadrature amplitude modulation QAM is a combination of what? Okay. Quadrature amplitude modulation is a combination of amplitude modulation, and because it is quadrature, so phase is going to matter over there. Phase shifting. So it is ASK and PSK. Okay. So option C, ASK, that is amplitude shift keying, and PSK, phase shift keying. Both this combination together is put into quadrature amplitude modulation, QAM. Okay. Then we'll go to next question, question number 68. In dash, the carrier of the carrier signal is varied to represent data. Both peak amplitude and phase remain constant. So here frequency, if you're varying to represent data, then it is frequency shifting, FSK. So here the answer should be BFSK. The frequency of the carrier is varied according to the information data to represent the binary 1 and 0. Okay. Then we'll go to the next question. Question number 69. How many carrier frequencies are used in BFSK, binary phase shift keying? Okay, so how many carriers are used? If the input data is binary 1, one carrier is used, and if the input data is binary 0, the other carrier is used. So carriers 2 are used in BFSK, one to represent 0 and one to represent logic 1. So here the answer should be option A, 2. So how many carrier frequencies are used in BFSK is 2. Okay. Then we'll go to question number 70. Dash uses two carriers, one in phase and the other in quadrature. Okay. So two carriers, one in phase and other in quadrature, is used by quadrature amplitude modulation, QAM. So here the option A will be the correct answer, QAM. Okay. Then we'll go to the next question, question number 71. Regenerative repeaters are used for, so options are eliminating noise, option B is reconstruction of signals, option C is transmission over long distances, and option D is all of the above. Okay. Now regenerative repeaters are the devices or circuits which regenerate a given pulse again. Say for example, the binary 1 pulse is transmitted on a transmission line. After it travels a certain distance, the amplitude of that pulse might attenuate. Now that pulse can be regenerated, a fresh new pulse of the same amplitude can be regenerated. Okay, so a new pulse can be regenerated. So it is working as an amplifier as we use in analog transmission. In digital transmission, we use regenerator repeater. So because we can generate a new pulse, we are eliminating the noise which had occurred till then. Okay, and also because we are able to regenerate a new pulse at various intervals of our transmission line, we can pass this information over long distances. That means all the first three reasons, eliminating noise, reconstruction of signals, and transmission over long distances, all of the above are the factors which are related to regenerative repeaters. Okay, so here the answer will be all of the above. Okay, then we'll go to question number 72. Polar coding is a technique in which, so options are given as A, 1 is transmitted by a positive pulse and 0 is transmitted by a negative pulse. B, 1 is transmitted by a positive pulse and 0 is transmitted by a 0 volts. C, both A and B, and D, none of the above. So polar means you are giving a value plus or minus. Okay, that means 1 is transmitted by a positive pulse and 0 is transmitted by a negative pulse. The option 1, the option A will be the correct one. So polar coding is done in which logic 1 is transmitted by a positive pulse and logic 0 is transmitted by a negative pulse. Then we'll go to question number 73. The polarities in non-return to 0 NRZ format use. Option A is complete pulse duration, option B is half duration, option C is both positive as well as negative value, and option D is each pulse is used for twice duration. Okay, now polarities in non-return to 0, you are not returning to 0 in between. That means it has to use a complete pulse duration. So here the option will be option A, complete pulse duration. Okay. Then we'll go to the next question, question number 74. The format in which the positive half interval pulse is followed by a negative half interval pulse for transmission of logic 1. Okay, now this format, that is, a 1 is first indicated by positive half interval and then it is indicated by negative half interval. Logic 1 is indicated in that way. This is done in Manchester format. So here the option will be option C, Manchester format, in which logic 1 is represented with half positive and half negative pulse. Okay. Then we'll go to the next question, question number 75. The advantage of using Manchester format of coding is, okay. So as we have said in Manchester, okay, logic 1 is represented by half duration by a positive pulse and half duration by a negative pulse. That means even if you are having odd number of ones or even number of ones, the number of positive pulse and negative pulse will be same and the DC level will be low, and therefore we will be saving, power saving is done. Okay, so power saving, that means answer A, power saving is done in Manchester format coding. Then we'll go to the next question, question number 76. In DPSK, that is differential phase shift keying technique, the technique used to encode the bits is AMI or differential code or unipolar RJ format or Manchester format. So as it is shown in the name only, DPSK, differential phase shift keying. So the answer should be, it is using differential code. B should be the answer, differential code. Then we'll go to the next question, question number 77. In coherent detection of signals, okay, coherent receivers, whether it is ASK or FSK, wherever you are using coherent detection, the local carrier is generated. It's very true, because you have to generate a local carrier. Then carrier of frequency and phase are same as the transmitted. Yes, it should match with the frequency and phase of the transmission carrier. The carrier is in synchronization with the modulated carrier. Yes, this locally generated carrier is synchronized with the modulated carrier. So all of the above in coherent detection, all of the above cases take place. Local carrier is generated, carrier of frequency and phase as same as transmitted carrier is generated, and the carrier is in synchronization with the modulated carrier. All this should match, then only it is called as coherent detection. And after that you are going to detect whether the input bit is binary 1 or 0. Okay. Then we'll go to the next question, question number 78. For a within bracket 7, 4 block code, 7 is the total number of bits and 4 is the number of what. Okay. So whenever you write the block code as 7, 4 or any other number, the first digit will give you the total number of bits, that is information plus redundant bits. And the second number will give you the information bits. That means here 4 is the number of information bits. So here answer should be A, information bits. Okay. Then we'll go to the next question, question number 79. Parity check bit coding is used for, okay. So whether it is odd parity or even parity, whichever parity generator you are having, parity check bit, whenever you use a parity check bit and at the receiver, you check the parity, and then along with that parity, if it is odd parity or even parity, you found any error, it is only error detection. It is not going to correct any error. So here the answer should be parity check bit coding is used for error detection. So B will be the answer, error detection. Okay. Then we'll go to the next question, question number 80. In alternate mark inversion, AMI, okay, the options are 0 is encoded as positive pulse and 1 is encoded as negative pulse. Option B is 0 is encoded as no pulse and 1 is encoded as negative pulse. Option C is 0 is encoded as negative pulse and 1 is encoded as positive pulse. And option D is 0 is encoded as no pulse and 1 is encoded as positive or negative pulse. So here the option D, that is 0 is encoded as no pulse and 1 is encoded as positive and negative pulses, that it is correct. Wherever there is 0, there is no pulse, but whenever 1 comes, the first one is represented by a positive pulse, the second one is represented by a negative pulse, again the third one is represented by a positive pulse, again the fourth one is represented by negative pulse. In this way, alternate marking of logic 1 will go on, and this is what the option says, that it is option D. 0 is encoded as no pulse and 1 is encoded as positive or negative pulse. Okay. So these are another 20 questions which I have taken in digital communication. If you are having any doubts or any feedback, if you want to give, you can send me a message. Okay. And if you are having any doubts, you can ask me. Okay. And again, I will tell you, for any subject, the basics of a given subject is important. Basics should be clear. Then only for attacking a multiple choice question, that theory, that policy, that logic will be very easy. Okay. Thank you, students.